Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International A-Level Potential Questions for Unit 5. Let us begin with Topic 16. Topic 16, Redox equilibria. In redox equilibria, actually, this is the easiest topic in Unit 5. They can ask you about the standard hydrogen electrode. Make sure you fully understand the standard conditions, the concentration of 1 mole per decimeter cubed, the temperature of 298 Kelvin, and the pressure of 100 kilopascals. There's some questions previously that have asked students to draw and label the standard hydrogen electrode. So please ensure that you understand how to draw this. And this could be the same way you can draw any gaseous involving half cell. They could also ask questions about half cells and full cells. So on this note, make sure you fully understand the components of the salt bridge and their uses. An example, if we have potassium nitrate in the salt bridge, you know that the nitrate is going to go into the half cell where oxidation is taking place in order to stabilize the charge, while the potassium is going to go in the half cell that is being reduced in order to ensure that the charge is maintained. They could ask you about cell notation, and again, this is usually section A, so please focus or make sure you fully understand cell notation. Ensure that you understand calculations involving electrochemical cells, also using calculated cell potential to predict thermodynamic feasibility of a reaction. This is the most common part, and this can be linked usually to vanadium and zinc. Zinc being used as a reducing agent, and vanadium moving from vanadium 5, vanadium 4, vanadium 3, vanadium 2, and so on. You also need to understand how you can link total entropy change and standard electrode potential. Again, from topic 16, they can ask about fuel cells. Make sure you fully understand the hydrogen-oxygen fuel cell. Remember, the negative electrode is the anode, where oxidation takes place, and the positive electrode is the cathode, where reduction takes place. Remember, hydrogen-oxygen fuel cells can be alkaline, or they could be acidic, meaning they can have an alkaline electrolyte or acidic electrolyte. So you ensure you fully remember the equations for oxidation as well as reduction, because these can be different in the different electrolytes. You need to know the advantages and disadvantages of using the hydrogen-oxygen fuel cell. You need to fully understand redox titrations and related color changes in reactions involving potassium manganate 7 with iron 2, as well as potassium manganate 7 with ethane dioic acid. Please remember that in these redox reactions, manganate 7 is converted into manganese 2, and iron 2 can be converted to iron 3, while ethane dioic acid is converted into carbon dioxide. So you need to fully understand the color changes that are going to occur. And finally, redox titrations involving iodine and thiosulfate. This is common in Unit 5, or it could come in Unit 6. You need to fully understand that as well. So from topic 16, ensure you fully understand that. Ensure you fully understand this part here, redox titrations, and then fully understand this part here, because those can come in Unit 5 as well as Unit 6. Let us continue to Topic 17. Topic 17, Transition metals and their chemistry. For Unit 5, this seems to be the most tricky topic, so you need to give it a lot of time, practice, and a lot of memorization that is required. They could ask you about the periodic table and electronic configuration of D block elements as well as transition metal ions. Please ensure that you keep in mind the electronic configuration of chromium as well as copper may be anomalous. You need to know to explain why some compounds like iron 6 chloride are not formed. To form a specific ionic compound, ionization has to occur. To ionize iron, until iron 6, there is a lot of endothermic ionization energy that has to be put in. So, if the lattice energy formed when the iron 6 as well as the chloride meet is not great enough, then it means it cannot compensate for endothermic ionization energy that was required. Therefore, iron cannot be oxidized until those very high oxidation states. So, reason this in terms of ionization energy, which is endothermic, and lattice energy formation, which is exothermic. Next, they could ask about characteristics of transition metals. Remember that transition metals have incompletely filled d orbitals. They have varying oxidation states. They form colored ions and compounds. They can act as catalysts. They have high melting and boiling points, and they are hard solids. Most questions that come in Unit 5 from Topic 17 as well as Unit 6 are going to be about ligands and complexes. So please learn how to represent a complex ion as a display 3D arrangement of bonds. You need to put the square brackets and put the charge. You also need to know how they are represented in equations without the displayed bonds. You need to know what a dative covalent bond is. You need to know about coordination numbers of complexes. You also need to look at page 188 of your textbook to fully understand how to name complexes. They are coming up in the new syllabus, so they could ask you to name specific complexes. Ensure that you can fully explain the origin of color. This is usually a 3-mark question. It comes a lot, so please make sure you emphasize on that. You need to learn about shapes of complexes and their corresponding coordination numbers, as well as bond angles. Of course, this comes as well. You need to understand that cisplatin is a square planar complex and it's used to treat some forms of cancer. You need to learn about monodentate, bidentate, and multidentate ligands and put emphasis on 1,2-diaminoethane as well as EDTA. You also need to learn to explain stability of complex ions when ligands with bi- and multidentate ligands are used in reactions. For example, if EDTA reacts with a hexa-aqua complex, the product is going to have more molecules and therefore more disorder and therefore more entropy because all the 6 ligands are going to be replaced by 1. So fully learn how you can explain increase in entropy of the system when complex ions react with bidentate as well as multidentate ligands. Now, looking at reactions that complex ions go through, they can ask you about deprotonation reactions. Ensure you fully understand how these reactions are and writing the equations. Remember, some reactions go through further deprotonation. And again, for this, deprotonation reactions can occur when these complex ions react with either sodium hydroxide or aqueous ammonia. And when they do, sometimes they form precipitates that go through to dissolve, and sometimes the precipitates may not dissolve. So learn about the deprotonation reaction, learn about ligand exchange reactions. An example is when HCl is used with copper and then you form tetrachlorocuprate from the hexa-aqua copper 2. Learn about redox reactions, reactions involving complex ions that go through coordination number change. Of course, like from hexa-aqua copper 2, which has coordination number 6, to tetrachlorocuprate, which has coordination number 4. In these reactions involving deprotonation, some of the intermediates formed can be amphoteric, so learn about amphoteric complex ions and the reactions that they go through. Some go through further deprotonation when you add extra sodium hydroxide, while to the intermediate formed when you add acid, it goes back to form the hexa-aqua complex. You need to learn the chemistry of copper complex until the formation of tetrachlorocuprate, including the colors formed and the reason for the formation of the green color. You need to learn the chemistry of chromium complexes and the colors involved. They ask a lot about chromium in Unit 6 as well as copper in Unit 6. That said, this can also come in Unit 5. So learn about the chemistry of chromium, all the colors involved. Remember, chromium 2 is blue, chromium 3 is green. There are 2 compounds in +6 oxidation state. One is chromate 6, which is yellow, and the other is dichromate 6, which is orange. You need to remember that. Also, you need to remember that chromium 3 can be reacted with hydrogen peroxide in the presence of alkaline to be converted to +6, which is yellow, chromate 6. Put focus on the interconversions between chromate 6 and dichromate 6, including the colors. You also need to focus on the chemistry of cobalt, ensuring you understand all the colors. Of course, these colors are very confusing, so you need to know. They know you're going to confuse it. Understand the chemistry of iron 2 and iron 3. This is also common. The chemistry of iron 2, iron 3, the chemistry of chromium, the chemistry of copper, those are very, very common, as well as the chemistry of vanadium, of course. The chemistry of vanadium, this is usually linked to topic 16, again about redox potentials and calculating the final oxidation state when vanadium in oxidation state +5 is reacted with zinc. In this case, zinc is acting as a reducing agent, so please focus on that. And the example is page 209. Look at that to fully understand how these calculations are carried out. They can ask you about the chemistry of zinc. And again, remember from your textbook, it's only zinc and chromium that will form solutions when excess sodium hydroxide is used. Finally, remember transition metals can be homogeneous and heterogeneous catalysts. Remember how iron 2 and iron 3 were used in the reaction between peroxide disulfide and iodide reactions. And also remember the autocatalysis in manganate 7 ethane dioic acid reaction. Topic 17 is the most detailed topic. It requires a lot of your hard work. You need to practice a lot. If you fully want to understand it, work with Unit 6 Question 1 past papers to fully ensure that you can solve any question that comes. So let's continue to topic 18. Topic 18, organic chemistry of arenes. To me, this is the most predictable topic. Of course, with benzene, they're going to ask you about the Kekulé structure versus benzene. You need to remember the evidence scientists use to decode the structure of benzene. Remember, they used evidence that benzene does not decolorize bromine water, yet compounds with carbon-carbon double bonds, like the theoretical Kekulé, should. There is evidence that benzene has only 3 isomers of dibromobenzene. The theoretical Kekulé structure should have 4 isomers. Scientists use evidence from X-ray diffraction suggesting that all 3 carbon-carbon bonds in benzene are equal in length, yet you expect that if there were independent carbon-carbon double and carbon-carbon single bonds, of course single bonds are going to be longer than double bonds, but from the scientific evidence, all of them had the same length, so that means the Kekulé structure is not the actual representation of benzene. Scientists also use evidence from infrared spectra showing the bond stretches involved. The carbon-carbon single bonds and the carbon-carbon double bonds have different stretches. However, with benzene, they found that they had the same pattern. Scientists also used evidence from thermochemical data showing the enthalpies of hydrogenation of benzene, cyclohexene, as well as Kekulé, which is the cyclohexa-1,3 triene, and they observed that benzene was completely different from the Kekulé they had predicted. Make sure you fully understand all those evidences scientists use. Now, other questions that are common from topic 18 are about reactions as well as mechanisms. They'll ask you reactions involving benzene, like the hydrogenation of benzene, using hydrogen in the presence of nickel catalyst. They could ask you about combustion reactions. Here, benzene is burned, but it burns with a smoky flame. You need to learn how to write the equation for this reaction. They could ask you about bromination with aluminium chloride or iron 3 chloride as halogen carriers. Please ensure you fully understand the mechanisms, including the reaction for the formation of the electrophile, as well as the regeneration of the catalyst. They could ask you about nitration of benzene with concentrated sulfuric acid and concentrated nitric acid. Ensure you fully understand the reactions, the conditions, the mechanisms for this reaction, as well as the reaction for the formation of the electrophile and the regeneration of sulfuric acid at the end. They can ask you about Friedel-Crafts acylation as well as alkylation of benzene. Remember that these reactions are carried out in the presence of halogen carriers. You need to fully understand the mechanisms, the formation of the electrophiles, as well as the regeneration of the catalyst. They could also ask about phenol. Common reactions are like bromination of phenol. Please remember that phenol is more reactive than benzene. Bromination can be carried out even if there is no halogen carrier. A deeper understanding of how incorporation of the lone pair of electrons from oxygen on the OH of phenol into the ring will cause the bromination of phenol to occur even at room temperature. These are some of the potential questions that could come on this. Ensure you fully understand these reactions and the mechanisms as well as the evidence that scientists used. So let's continue to topic 19. Topic 19, organic nitrogen compounds. They will ask you about amines and their preparation. Fully understand preparation of aliphatic amines. An example, we could produce them from halogenoalkanes by heating the halogenoalkanes with ammonia in a cell tube. Ensure you understand the equations for this reaction. You could also produce these aliphatic amines from nitriles. Reduction of nitriles using the lithium tetrahydride or aluminate in dry ether. They could also ask you about preparation of aromatic amines. One good example is the reduction of nitrophenol to produce aminophenol in the presence of tin and concentrated hydrochloric acid. Please ensure you fully understand the equations involved with this reduction. They could ask about reactions of amines, like how they react with water, and the basicity of primary, secondary, tertiary, and aromatic amines, meaning which is a stronger base and which is a weaker base. Here we need to understand that aromatic amines are weaker bases compared to the others because the lone pair on nitrogen is incorporated into the ring and therefore will not be easily available to be donated to any incoming electrophile. Among aliphatic amines, increasing inductive effect increases basicity. They can ask you about reactions with ethanol chloride to form amides. Remember, this reaction type is an addition-elimination reaction. They can ask you about reactions with copper-2 ions. Copper-2 ions or hexa-aqua copper-2, these are going to be complexes. However, when you react them with amines, these amines are going to act as ammonia does act in the redox reactions you saw in topic 17. Please ensure you fully understand this. And finally, most common questions about formation of azo-dyes. Please focus on page 244. Remember the conditions for coupling reactions in azo-dye formation. Other questions could be asked about amides and polyamides. They could ask you about preparation of amides by mixing acyl chlorides and concentrated aqueous ammonia. They could ask you about polyamides, including nylon 6,6. Ensure you fully understand how this is produced. Remember the monomers used in the formation of this polymer. They could ask you about Kevlar and its uses, polypropionamide as well as polyethanol. Ensure you fully understand the uses of these polyamides. Sometimes they could give you a polymer and ask you to separate it and write the monomers that have been used to produce the polymer. Other questions could be asked about amino acids. Please ensure you fully understand the general structure of an amino acid. Remember, it has an amine group as well as a carboxylic group. Remember to name amino acids using the IUPAC system. Remember the amphoteric nature of amino acids, including reactions that lead to salt formation. Remember, sometimes the amine group is going to gain a proton to become ammonium, while the carboxylic group is going to lose a hydrogen to become a carboxylate. Remember, amino acids are zwitter ions, meaning they can be electrically neutral because they can have a positive and negative charge, so they can be electrically neutral. Remember optical activity of amino acids. They have a chiral center, so ensure you do not forget that. When we look at proteins, make sure you know how to draw a dipeptide. I don't think they'll ask you to draw polypeptides, but ensure you fully understand combining two amino acids to produce a dipeptide. Ensure you fully understand the analysis of proteins by hydrolysis into amino acids, and then using chromatography to identify the amino acids in the presence of dyes like ninhydrin. Ensure you fully understand chromatography, identification of proteins by hydrolyzing specific proteins to produce amino acids that can be separated and identified using their RF factor. So this brings us to the end of topic 19. Let's continue to topic 20. Topic 20, organic synthesis. This topic is mainly a summary of everything you have covered. So questions can be asked. Questions about analysis of compounds, like empirical formula as well as molecular formula calculation. They could ask you about combustion analysis. Remember, most combustion reactions are going to produce carbon dioxide and water, so we could use those to be able to get the mass of hydrogen, the mass of carbon, as well as the mass of oxygen in order to calculate the empirical formula as well as the molecular formula of an organic compound. They could ask you about functional group tests. Please ensure you understand Table A on page 261. It shows you all the functional groups that can be tested. They can ask you about mass spectroscopy. Talked about this in Unit 4. They can ask you about infrared spectroscopy. You also talked about this, as well as NMR spectroscopy. This was talked about in Unit 4. That was talked about in AS. Ensure you fully revisit those topics and understand because questions can be asked about them. The other part is organic synthesis. The synthesis I've put here is extracted from your textbook. They can ask you about conversion of a halogenal alkane into an alcohol and an alcohol back into a halogenal alkane, alkene into an alcohol, carboxylic acid into an alcohol, this is reduction of course, aldehyde into an alcohol, that is reduction, alcohol into aldehyde is oxidation with potassium dichromate in the presence of sulfuric acid. Conversion of an alcohol into a ketone, that is going to be oxidation, while a ketone back into a secondary alcohol is going to be reduction. An ester into an alcohol, of course, it's going to be hydrolysis in the presence of an acid, like sulfuric acid. Conversion of an alcohol back into an ester, that could be esterification, whereby a carboxylic acid is reacted with an alcohol. It could also be reaction of an alcohol with an acyl chloride. Conversion of an alcohol into a halogenal alkane, depends on which halogenoalkane you want to form. If you are forming a chloroalkane, like primary, secondary, you could use PCl5. If you're producing bromo, you can use a combination of KBr and sulfuric acid. And if you're forming iodoalkane, you can use phosphorus with iodine. Other questions that could come are extension of a carbon chain. This is very common, and I prefer you fully understand all these reactions. They could ask you reactions of halogenoalkanes with KCN, introducing CN to form a nitrile. And actually, this is a nucleophilic substitution reaction whereby the halogen is substituted by a CN to form a nitrile. They can ask about reactions of carbonyls with KCN-HCN. These are the nucleophilic addition reactions. Ensure you fully understand this mechanism as well. We talked about this in topic 15. They can ask about extending the carbon chain by alkylation as well as acylation. Reaction with Grignard's reagent. Ensure you fully understand which products you form. For example, if I react carbon dioxide with Grignard's reagent, I form carboxylic acids. And when I react Grignard's reagent with methanol, I form primary alcohols. If I react with other aldehydes, I form secondary alcohols. And with ketones, I will form, or you will form, tertiary alcohols. The last part is about the practical techniques. This is very common. These are very common in Unit 6 as well. They can ask you questions involving heating under reflux. They can ask you to draw labor apparatus used for heating under reflux, simple distillation. They can ask you about steam distillation. This is usually if it's drawn or if it's half drawn and they ask you to complete. Steam distillation and its advantage in preventing the decomposition of substances. You need to fully understand fractional distillation, fully understand solvent extraction using a separating funnel, and you need to remember the details of every step, including the suitable drying agents that can be used if an organic liquid is produced. Remember, those drying agents should all be anhydrous. They can ask you about the recrystallization process. This is really hard for some students to understand at first, so ensure you fully remember all the steps, the reasons for filtering when hot, filtering when cold, washing with a cold solvent, and so on. And lastly, melting point determination. Ensure you fully understand how to draw, label, and describe each step in detail because this question came previously and it was about 5 marks in Unit 6 mainly. So fully understand this. I have taken some time to lay out the steps in recrystallization to ensure that you fully understand because I've seen this with some students, it gives them a hard time. Recrystallization, the first step is to dissolve the crystals in minimum amount of hot solvent. The reason for using a hot solvent is to ensure that the dissolution occurs fast so that less solvent is used. If more solvent is used, then it may be hard to recrystallize when cooling takes place, meaning some of the desired sample will still be dissolved, which is going to decrease the sample size. Step 2 is to filter the sample when hot. Filtering when hot ensures that any insoluble impurities are removed. If there are no insoluble impurities, then you can skip step 2, just go to step 3. In step 3, you cool the crystals so that the desired sample crystallizes. Here, the soluble impurities will not crystallize out because they will remain in the solvent. The reason for this is the concentration of these impurities is really small, so they cannot come together that fast or that much in order for visible crystals to be formed. Step 4, we filter the sample under reduced pressure. You do this using a batch and a funnel. Ensure you fully know how to draw this because sometimes they can ask you to draw and show the apparatus used. The desired sample will remain on the filter paper in the funnel. The solvent as well as the soluble impurities will go through and be collected as the filtrate. In step 5, we wash the crystals with ice-cold solvent to remove any impurities. The purpose of washing is to remove some soluble impurities from the obtained crystals. And again, we know some impurities are going to be stuck on the crystals we've collected, so you wash using ice-cold solvent. And again, remember that both the soluble impurities and the desired crystals are soluble in this solvent. So when we use ice-cold solvent, we want to ensure that less desired crystals are lost in the washing process. So, guys, the steps in recrystallization are this brief. This is usually a Unit 6 question, but I cannot say it cannot come in Unit 5, though rare, mostly it's in Unit 6. So this brings us to the end of this video on the sample questions from Unit 5. Thank you for being with us. Don't forget to subscribe. See you in the next video. Bye-bye.